Factoring a trinomial, Algebra 1 review, okay. Our objective for this lesson is to be able to factor a trinomial by using guess and check, organized factoring, and difference of squares. This is reviewing all the factoring skills that you spent a lot of time on in Algebra 1, but may have forgotten. So we're going to review these skills again, so as kind of a reminder of remember when we did this. Okay, so first we need to talk about what it means to factor. Okay, this word comes from factoring is when I multiply two numbers and get a new number. Each of these things I'm multiplying, I don't know, take 2 and 6 and I get 12. The 2 and the 6 are what we call factors, and their product is 12. So 2 and the 6 are the factors because there's the numbers that I multiply to get to 12. Okay, 12 has other factors besides 2 and 6. Other factors of 12 would be 3 and 4 because 3 times 4 is 12. Okay, so numbers have many factors. Okay, so our goal here is to figure out what two things can we multiply to get to our polynomial. Okay, so here I have a trinomial. It's got 3 terms, 1, 2, 3 terms, trinomial. And I want to figure out what do I multiply to get to this right here. Okay, the first method that you learned back in Algebra 1 was just guessing and checking, meaning we just tried multiplying two things and saw if we got back to here. Okay, so my first term needs to be products of 2x to the second. So what do I multiply to get 2x to the second? Well, what can I multiply to get to 2? Well, that's just 1 and 2. So we're going to have 1 and 2. And I'm going to have to multiply x times x to get to x squared. So we're going to need 1x and 2x's. Okay. And now what do I multiply to get to 1, the last term? Okay, so to multiply to get to 1, I need a 1 and a 1. That's the only numbers that will multiply to get me to 1. And now I need to debate, do I add and subtract in between? Do I add? Do I subtract? What do I do between these two terms? Okay, but I need to get to a negative 1, which if both of these ones are negative, if I have minus and a minus, it would be negative 1 and negative 1, which wouldn't give me a negative 1 when I multiply. Okay, so we're looking at our guessing and checking. We could try it. We could try and both subtract and then multiply. So now we're just distributing. X times 2x is 2x squared. X times negative 1 is negative x. Negative 1 times 2x is negative 2x. And negative 1 times negative 1 is positive 1. So I end up getting 2x squared minus 3x plus 1. So it didn't work because my middle term is a negative 1x and my last term is a minus 1. So we guessed, we checked it, it didn't work, so let's switch a sign. Let's see, let's try a plus here in between. Since my first and my last worked out almost, then we probably want to leave those numbers the same. We just need to switch our signs. So now let's try again. So I switch this to a plus, let's try again. So cross that out, let's try again. X times 2x, that's 2x to the second. X times negative x is negative x. X times 2x, that's plus 2x. Sorry, negative 1 times 2x. Positive 1 times negative 1 is negative 1. So I get 2x squared plus x minus 1. So now let's double check. Did it work? Almost. Only thing is here's a positive and it needs to be a minus sign. So these things need to switch. Make this one a minus and that one a plus. Let's try again. X times 2x. 2x squared, x times 1 is plus. Negative 1 times 2x is negative 2x. Negative 1 times 1 is negative 1. So we get 2x to the second minus x minus 1. It worked. So this is how this thing factors. Okay. All right, let's do another example. So again, I want to multiply to get a 1x squared and then a 12. So let's go ahead and multiply to get 12. Okay, so let's go ahead, let's try it. What can we try? 1 and 12? Everything's adding, so let's go ahead, let's go with it. So we'll have x squared plus 12x plus 1x plus 12. So I get a 13x here in the middle. That didn't work. I want a 7x in the middle. And I'm wondering if you remember from Algebra 1, where you want to multiply to get this last term, but add to get the middle. So I want to multiply to get 12, but add to get 7. So what multiplies to give me 12? So let's see, what multiplies to give me 12? 1 and 12, 2 and 6, those don't add 7, that adds 8, 3 and 4. When I add those, I get 7, so we'll go 3 and 4. X squared, so let's try it. We got x squared plus 4x plus 3x plus 12. There's my middle term, there's my 7x. So here is how they factor. One thing I like about factoring is you can always check your work, multiply it out, make sure you get back to where you started. Okay, now pause the video and I want you to do your turn number 1. Okay, all right, another method for organized factoring, another method for factoring, besides guess and check, is organized factoring. Organized factoring is nice when your leading coefficient and your constant term have way more factors than just like 1 or 2 of them. Because if you have a lot of factors, if there's a lot of numbers that multiply to give me 6, you could be guessing and checking for a long time until you find one that works. So what we do what we call organized factoring. So if we notice here, I've got a 6 for my first term and a -3. Again, I'm going to write this, so this is a -3, right? Plus a -3. Sorry, my hand was in the way. -3 right there. So what I'm going to do is I'm going to take this 6 and this -3 and I'm going to multiply them. 6 times -3 and I get -18. Now, I want to find factors of -18 that add to give me that 7. So let's see, 1 and 18. 1's going to have to be negative when I add those, because to get a -18, when I add those I get 17. That doesn't work. Okay. What about 2 and 9? 1's going to have to be negative. Hey, that worked. -2 and 9. So now what I'm going to do is I'm going to come in and I'm going to rewrite the 7x as a -2x and a 9x. So I'm just making this, instead of 3 terms, I'm now turning it into 4 terms. So we have 6x squared minus 2x plus 9x minus 3. Before you go on, double check and make sure. If I was to simplify this, put together like terms, and go backwards, I'd have to where I started. I've put these together, I get 7x, and it gets me back there to where I started. Okay, now I'm going to group them. Do not get this confused with factoring. I don't have it factored yet. I'm just going to group the first 2. I'm going to put these 2 together. There's still a plus sign in between here, and put the last 2 together. So basically, I'm just using my associative property, putting the first 2 together and the last 2 together, but there's still an add in between here. It's not a multiply yet. And now I'm going to factor out a common factor from both of these. What do these 2 things have in common? Well, between the 6 and the 2, I can take out a 2. Between the x's, I can take out an x. So I'm left with 2x times what is 6x squared? Well, times 3 in the x. And 2x times -1 gives me that -2x. Plus, now what can I factor out of these 2? What do they have in common? Looks like a 3. 3 times 3x gets me 9x, and then 3 times a -1 gets me the 3. So now if you notice, they have something in common. The first thing and the last thing both have a 3x minus 1. So I can take this 3x minus 1 and put it out front. And what am I left with? 2x plus 3. Okay, so to make sure I did this right, I'm going to multiply. So let's go ahead and let's distribute. 3x times 2x is 6x to the second. 3x times 3 is 9x. Now, -1 times 2x, -2x. -1 times 3, -3. So 6x squared, that would give me plus 7x minus 3. So it worked, got me back to where I started. So here's how it factors, right there. Okay. All right, let's do another example. So again, we're going to organize factor this. So I'm going to take the first term, the leading coefficient, what's in front of my x squared, and my constant. So 2 times 20, which is 40. Okay. So now I want to multiply to give me 40, add to get -13. So that tells me they're both going to have to be negative for me to multiply and get a positive 40, add to get a negative 13. So I'll have negative 1, negative 40, well, that's negative 41. Negative 2, negative 20, negative 22. Negative 4, negative 10. That is negative 14. Negative 5, negative 8. I think that works. There's my 13. Okay, so I'm going to replace this negative 13x with that. So I'll have 2x to the second. It doesn't matter which order you put them in. Okay, so now we're going to group. Put the first two together. I'm going to rewrite this as plus a negative 8. So I don't lose track of where that negative is. It's on the 8. So I group the first two and the last two. Again, that plus sign's still in between. Now out of these first two, oh, the only thing I take out is an x. So we would have 2x minus 5. Out of these, I can take out a negative to make that first thing positive. I could take out a negative, 4? And I'm left with 2x, negative 4, negative 5. Now, if you organize factored right, you should get to a point where they each have a term in there that's the same. That 2x minus 5 is the same in both of them. So what's left? An x minus 4. Let's double check our work by multiplying. Let's take 2x times everything here. 2x times x is 2x to the second. 2x times negative 4 is negative 8x. Negative 5x times x, negative 5x. Negative 5 times negative 4 is positive 20. So we have 2x to the second minus 13x plus 20. Let's see. Yep, it worked. So there it is factored. Okay, now pause the video and go do your turn number 2. Okay. All right, difference of squares. Okay, if you remember from our square root discussion, we talked about our square numbers, like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, so forth, 6 squared. Okay, so we should be pretty familiar with our square numbers. If I have a difference, again, difference is only subtract. If I have a difference of squares, of square numbers, I can factor it. If I have a difference, a squared minus b squared, if you remember, it factors into a plus b, a minus b. Again, the thing I'm squaring and the thing I'm squaring. Okay, so if I can notice that we've got difference of squares, I can factor it very, very quickly. Okay, so first we have to look, does it fit the pattern? First of all, is it a difference? This is a difference. Okay, is it a difference of 2 squares? Well, think about it. Is 4 a square? Yes, it's a square of 2. Is x squared a square? Yes, it's a square of 8x. So if I take 2x and square it, I get to here. So if I take 2x and square it, I get there. And what about 5? Is 5 a square? Yep, it's a square of 5. So 25 is a square of 5. So this is something squared, this is something squared, and it's a difference. There's my subtract. So I can factor using difference of squares. So then I just take the things that I square, the 2x and the 5, I add them, and I subtract them. And then, doesn't hurt to check your work, let's multiply this out. 2x times 2x, 4x to the second, 2x times negative 5 is negative 10x. Now let's multiply by the 5. 5 times 2x is plus 10x. 5 times negative 5 is negative 20. So if you notice here, my middle terms cancel out. I'm left with 4x squared minus 25. So it worked. Okay, example 3. Again, so we're looking for, it's a difference. Yay, that's good. And it's the difference of, are these squares? Well, this is the square of x. This is the square of 4. 4 squared is 16. So this is going to factor into x plus 4, x minus 4. Again, if you're not sure, distribute out. X times x, it's x squared, minus 4x, plus 4x, minus 16. X squared, those cancel out. X squared minus 16. Yep, so here's how it factors. Okay, now pause the video and do your turn number 3. All right, now we're going to notice a pattern. what's called a perfect square trinomial, okay? It's just a pattern that pops up quite often. We're gonna go ahead and we're gonna factor this. We're just gonna factor this right here. I'm not gonna, we could factor it anyway. First of all, I can't do difference of squares because it isn't a difference. It's adding, and it's trinomial. There's 3 terms. Difference of squares will only have 2. Okay. My leading coefficient's 1, so I think I'm gonna guess and check. So let's factor this using guess and check. Well, it multiplies to give me x to the second. X and x. Now it multiplies to give me 16. But again, keeping in mind, I want to add to get that middle term, that 8. So it multiplies to give me 16. 1 and 16, 2 and 8, 4 and 4. Add those 17, add those 10, add those 8. Hey, that works, 4 and 4. So we can distribute this out. We get x squared plus 4x plus 4x plus 16. So it worked, x squared plus 8x plus 16. But if you notice, I've got 2 of them. They're the exact same factor, x plus 4 and x plus 4. So in much the same way, if I have 2 of the same factor, if I take 3 times 3, we would shortcut that and write that as 3 to the second. Here I have x plus 4 times x plus 4. We're going to shortcut that and write that as x plus 4 to the second. Caution right here. This does not mean this is not equal to x squared plus 4 squared. Not equal to that. Because as you can tell, it's equal to x squared plus 8x plus 16. You lose that middle term if you multiply incorrectly. So this is just the shortest way of writing it is x plus 4 quantity squared. Okay. All right, so here let's look at example 4 again. My leading coefficient's 1, so that tells me a good idea is to guess and check. Whenever your leading coefficient is 1, you have nothing in front of your x squared there, guess and check's your best method. It's the quickest because I don't need to worry about my factors of my leading coefficient. It's just going to be x and x. Factors of 9, when I add, I get negative 6. So 3 and 3, I think 3 and 3 is 9. Oh, but they both have to be negative to get negative 6. Let's double check it. We'd have x to the second minus 3x. Multiply those two, minus 3x. Negative 9 times negative 9. Negative 3 times negative 3 is plus 9. So it worked. But again, I can shortcut this and write it x minus 3 quantity squared. Okay, now pause the video and do your turn number 4. Hint, hint for your turn number 4, rearrange it. It's not in a very nice order. Rearrange it, okay? So you need to come to class with all of the your turn problems done. There's 4 of them. So your turn problems 1, 2, 3, and 4. You need to have all 4 of those started, something attempted before you come to class tomorrow. Good luck.